Okay, so this paper is on trustworthy artificial intelligence for blockchain-based cryptocurrency. Okay, so specifically for Bitcoin, Bitcoin is a cryptocurrency that uses blockchain as a public transaction ledger. Blockchain is a decentralized database layered with a consensus mechanism that allows participants to agree on what gets saved to that database. And miners validate each transaction before transactions are added to that ledger. And these miners are rewarded with new Bitcoin, but as the supply of Bitcoin reaches the maximum threshold, these rewards decrease. As a result, the supply of Bitcoin remains static while the demand rises and falls, and this causes a high volatility compared to traditional stock and indexes. Now, the question is of whether a deep neural network can learn the behavior of Bitcoin despite its high volatility. And previous studies have shown that deep neural networks do not perform better than traditional statistical methods. And on to related work. So no previous study has been shown a significant improvement in using a deep neural network when compared to linear SVM or logistic regression models. And in 2015, a study by Almeida noted that past studies have failed to train neural networks, not because of the extreme fluctuations in price and volatility, but mostly because of incorrect data preprocessing, and this led to many other problems. So their final results show that the simple neural networks performed better or made higher profits than complex existing networks. And based on a study done by Zhang and Li in 2017, one of the major issues with past studies is that they don't take into consideration the internal blockchain parameters that influence the Bitcoin network, along with macroeconomic indexes. So because of the large amount of training parameters, 26 in total, they decided to use a Bayesian network for their neural network. And they were careful which input parameters to include for training, because not all were necessary and they could possibly skew the results. So their results showed that the BNN achieved a lower root mean square error when compared to linear regression and support vector regression. So taking these related works into consideration, we can develop an approach so that we know that stock price prediction is challenging because of the number of variables that can influence the price. And these variables could be events that are external or internal to the company. The events may not be known about until they have already happened. Bitcoin is even harder to predict since initially predicting Bitcoin prices didn't even adhere to outside business influence in government, so it is instead based on a shortage of the coins themselves. However, in the recent years, this has changed a bit as Bitcoin has come to the spotlight. And as more businesses start using cryptocurrency to raise funds, the United States Exchange Commission has become involved and started to enforce rules to regulate cryptocurrency. So to tackle all of these challenges of the different variables going to the cryptocurrency, like a majority of the other references, I use the linear regression, support vector regression, logistic regression, and time series prediction as the baseline models to which I compare a deep neural network. The algorithm I chose to implement was backpropagation and stochastic gradient descent integrated with 3 types of neural networks: shallow, deep, and wide. And onto the data. So I found that with response or target prices, target variables, I set them to price and volatility. And in the past couple of years, both of these have intense fluctuations uncharacteristic of traditional currency markets. And table 1 shows all of these variables, including minor revenue percent value and average block size. So 4 sources were used to make 3 data sets, where sources 1, 2, and 3 were used for blockchain-related data. And although similar, I believe that there are slight differences due to difference in collecting times. And source 4 was used to collect macroeconomic indexes, and because these values were similar to other sources, source 4 was used in all 3 data sets. So I used the time range from September 2011 to August 2017 for all of the parameters. And one major observation that I found was that The response variables and the blockchain-related variables in 2016 and 2017 were significantly more volatile than the macroeconomic indexes. And on the contrary, there's little change in the global macroeconomic indexes. And this could mean that Bitcoin price and volatility fluctuations derive from the blockchain variables and not because of macro financial markets. And onto the main setup of this test is to perform a baseline linear regression analysis on all three datasets, and then compare the results to the neural network models. And after performing linear regression, the root mean square error and mean absolute percent error were calculated. And I trained 3 different neural network models on the 3 datasets, these models being a single hidden layer shallow model and a 3 hidden layer deep model and an overcomplete single hidden layer wide model. So the neural networks were trained through a 10-fold cross-validation and 1,000 epochs. Additionally, the data was split between 80% training and 20% testing. And lastly, so the following tables summarize the results of all of the models from each dataset. And the neural network outperformed linear regression in all datasets for log price and log volatility. The log price was known exceptionally well, where the root mean square error was less than 3 times of the linear regression. And training errors and testing errors were 2 to 3% for the neural network models, while test errors were 7 to 8% for the linear regression. Furthermore, it appears that all 23 variables help the neural network learn. This suggesting that a neural network is better equipped to handle variables that are highly correlated. And within the neural network models, a deep model outperformed the shallow and wide models significantly for log price. Log volatility was harder to predict due to high fluctuations in the raw data, and the performance increase using a neural network wasn't as high as it was when we were predicting log price. And to conclude, so blockchain is an emerging technology which promises security and true decentralization, with cryptocurrency being its first widely used application. In this project, I showed that neural networks trained with blockchain and macroeconomic variables have stronger predicting power than linear regression. And in the future, I would like to see how a neural network would predict Bitcoin prices with its current trend compared to the data I used in this paper. And then that's it. Thank you for listening.